The University of Pittsburgh Graduate Studies team is pleased to introduce our finalists and their research in the 3MT competition. The 3MT, or 3-minute thesis, challenges doctoral students to effectively explain their 200-plus page dissertations to a general audience in just 3 minutes. Please enjoy this presentation by Ande Marini, PhD candidate who won the School of Engineering competition. In the university-wide 3-minute thesis competition, Ande went on to be a runner-up.
Hello, my name is Ande Marini, and I am a fifth-year PhD candidate in the Department of Bioengineering. Today, I will be giving a talk about my thesis research on regenerative treatments for abdominal aortic aneurysm repair. Abdominal aortic aneurysm can be described as the ballooning of the major artery that carries blood from your heart to the rest of your body. And like a balloon, as it continues to expand over time, it can eventually rupture, which carries an 80% mortality rate. And half of you won't even make it to the hospital in time for any kind of surgical repair. It's also difficult to do any kind of surgical intervention given the location of this aneurysm, as it's behind your vital organs. Essentially, clinicians have come up with a diameter criteria that states once your aneurysm reaches a particular size, your risk of rupture is now higher than your risk of surgical complications. But there's still a possibility your aneurysm could rupture before it even reaches this size. So what do you do for patients like this? Well, in our lab, our goal is to create a regenerative medicine treatment that actually addresses the root cause of these aneurysms, which is loss of vascular wall integrity due to loss of the structural protein known as elastin. Elastin is responsible for giving blood vessels the ability to respond to blood flow without continually expanding. With our treatment, we intend to take the secreted factors from stem cells, which we call extracellular vesicles, or EVs for short, and package them very nicely into silk iron microparticles. This will combine the regenerative properties of stem cells, plus the biocompatibility of silk, and the magnetic movability of iron oxide nanoparticles, thus creating a magnetically localizable regenerative treatment for abdominal aortic aneurysm repair. We've already shown that these EVs can in fact be encapsulated in our microparticles, then released and taken up by vascular smooth muscle cells, which are key players in restoring that vascular wall integrity, as they are the ones responsible for creating the new elastin. We also have 3 steps we hope to deploy clinically. The first is injecting our particles on the outside of the aneurysm. The second is then putting a magnet on the inside of the aneurysm to pull our particles closer to the vessel wall, allowing them to be localized more. And third, we are deploying them in a hydrogel that is designed to gel around the outside of the aneurysm to hold our particles in place for a longer period of time, allowing them to have a longer and more regenerative effect. We also have 3 main goals with this project. The first is halting aneurysm expansion altogether. The second is actually addressing the root cause of these aneurysms by restoring that vascular wall integrity through synthesis of new elastin. And third, and what I find most importantly, is we're finally giving these patients peace of mind who currently have no treatment for their aneurysm. And I think that sounds pretty attractive. Thank you.